or rather I would say further with what you were doing. I take a departure stance from your doubts first, and then we'll be in furtherance with what we were doing. I'll be adding a few from my end. I want a few from your. So as I want a few from you, please let me know, Vasudev, which question, where hiccup, what concepts you are as of now grappling with. Those can be taken and those can be straight through the bat done. After that, I'll come to Ishita and then Vibha. Yes, please. Vasudev. I'm straight off the bat, all your doubts. Straight off the bat, all your doubts. Tell me, dear.
So I do not have any specific thing I'm grappling with right now. If I had forewarning of this, I would have made a list. But right now I do not have anything on my hand. Maybe I can come up with something. Maybe I can go second or something. I'll have some time to collect everything.
Okay. Please go ahead.
So I just said I do not have anything in specific that might contribute to this class.
Okay. In the due course of time, you may get something which you will be able to. It's not about just contributing to the class, it's also about clearing your backlogs, if you do have any, right?
Yes, right now I do not have any significant
So
ones.
recollect in the due course of time, no issues. I pass on to Ishita. Ishita, tell me anything that you wish to ask.
From any
You
chapter.
have something itching for long. Yeah, Ishita.
Okay, I got to get my workbook for that. Probably I marked a few questions. Would you just give me a minute?
Please get no issues. Beba, in the meanwhile, you'll share some of your doubts or your question that you were not able to solve.
Sir, I've not got any doubts on me. That all the concepts are clear as I covered.
You were getting 30, you said 4 marks you have lost. Where have you lost 4 marks? That you should be aware of and accordingly ask doubts on it. Nevertheless, you have not one doubt, you have many a doubt. So I'll start with my doubt. There's a question which goes with a semi-infinite wire carrying certain current I, and then that current distributing in a plane. There is a semi-infinite wire. Let's say it's in vertical orientation. Semi-infinite wire in vertical orientation. So one end, the end at the top is not, let's say, visible to us. The end visible is down, and down is where it spreads into a sheet. Top is a wire, the end is not visible to us, but down where it culminates, it spreads into a sheet. Down it's culminating, it is spreading into a sheet, or you can say a circular sheet of infinite dimension. By that what I mean, certainly center of circle is very much visible, but the periphery isn't. The disk that we are speaking of, center of the disk is visible, but the periphery isn't. It is spread up to infinity. Are you getting the concept, class, over here?
Yes.
There's a wire, I repeat, there's a wire, vertical orientation, end of the wire, top end of the wire is not visible to me. But what is visible is spreading of one of its end in a disk. And that disk has got its periphery at infinite. So it spreads from the axis up to infinite distance. Am I clear on this? Let me show it to you. Let me show it to you over here. What I'm trying to suggest. So this is the case. Please look into it. Let's say there is a wire going this way, down, 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 down. Are you getting it? This way, up of wire not visible to me. That is the other end of the wire over here is spreading into a sheet. Spreads into a sheet, and this sheet is of infinite dimension. It spreads up to infinity. Are you getting it? So spreading everywhere up to infinity. Periphery being not visible to me is visible the center. And the other part also visible, nevertheless, periphery is not visible to me. So I current spreads on this disk. What being asked is the B field here above the green and below the green. B field here above the green and below the green. Let's start with one. B field over here, anywhere above the green. What will it, how we will calculate B field above it? A very important question, a question which has not much of theory to do with, much of black and white to do with, but it is a hat off when it comes to, I will really doff my hat off when it comes to articulation and examining it on three-dimensional basis. So let us try to analyze it. How will you get head and tail of it? Anyone? Please feel free partaking. These are the questions we ought to partake. It's not a monotonous solving, as you are aware of how we do proceed. Let me know the process. By the way, Ishita, this is Vasudev and Vibha. They are joining us from Bangalore. Vasudev from Mysore to be precise, and Vibha from Bangalore. Okay. Got it, dear? Ishita is an old acquaintance. She was there in 2001, right, Ishita?
So 2001?
Sorry,
2021.
221. When she dropped for the preparation, she has taken a drop for preparation and is back with us. Yes, Ishita, 2021. Okay. So tell me, dear, how to go about it. Any one of you, please take the lead.
So you're saying basically we need to find the magnetic field on any point on the wire itself, right? The wire that's going into this.
Point. Anywhere on. No, I am not referring it to one. There's no caveat as such, no rider. Anywhere here. Above the green, anywhere below the green.
Are you suggesting the field is constant?
Field is constant.
Or you're
I'm
saying
not suggesting anything. You cannot make anything. Don't extrapolate what I'm going to ask.
yes.
So let's start from scratch. You do suggest accordingly. I would try to somehow unscramble it with a jigsaw puzzle being put at place.
So I'd assume at least a component of this magnetic field would be produced by the wire itself.
Okay.
And the other component would somehow be contributed by the current flowing in the circular sheet. I mean, the first
One you are we are right on. One will be produced by the semi-infinite wire as the terminology that we use. What about the other part of the same field, or what about the other part of the same wire? There'll be only one part when the wire being taken into consideration. You are referring to, I presume, this wire. So what I'm to do, I'm to take my right hand, thumb in the direction of current, curl my finger. So I'll curl my finger, I'll get B field in this direction. Okay, got it. Over here, anywhere you take B field, let us take it on x-axis first, negative x-axis. This is my negative x-axis. So if I take it over here, just above of it, curling my finger, I get it in this direction, right? Think about it. I'm not here, I'm up. I'm getting in this direction, correct?
Yes, sir.
Due to this part, the semi-infinite part, curling a finger, I get in this direction. Okay,
Yes.
got it. That we know the value mu naught 4 pi I by r being the perpendicular distance, got it. What about this part? The crux of the matter lies in this part. What we feel will get produced going to this spread, this one. That's what is being asked. what to say? Let us take one wire. Let us take one wire, this wire, and try to figure if I prime is the current this wire, I prime this way, I prime this way. I prime this way, and then pointing to this wire and this. What will be field over here? This point. Which direction? Is very analytical question. Try to understand. Here, above it. At this point to this orientation and this orientation. What current? I prime this way, I prime this way. So here I want to find at the same point over here, let's say, just above it, what will be direction of B field? Firstly, due to this. So this is nothing but a semi-infinite wire again, correct? This wire carrying whatever current is again a semi-infinite if I take from here, going up to infinity right here. From here, the center, going up to infinity, this again is to tantamount to an infinite, or we let us say in the mathematical term which is not justified, so I'm saying infinite. In the term of physics, we say semi-infinite, one end visible, the other end not. So semi-infinite, what do we do? In the case of semi-infinite, just a minute. Sorry. Okay. In the case of semi-infinite, what do we get over here? Is a B field. What will be the value of B field? Mu naught 4 pi I, the current in it, divided. But that will not be the exact case. Why? Because I'm calculating it over here. Are you getting the change here? When you took this one, this wire, then we're calculating over here, it's okay. You curl your finger, you got in this direction. But when you're talking of this wire, this wire is of what kind? This wire has got field to be calculated over here. That means I'll have to calculate what angle. I'm showing it over here. This is the wire, let us say, that I'm referring to. Or I'll make in the orientation which I'm solving. This is the wire that I'm referring to, right? This is the axis. Check it out. This is the axis.
Yes.
Keeping our camera in the orientation so you're able to understand.
Yes.
This is the axis. I take the axis over here, and this is the wire to me. This is the wire I'm referring to. Now, where do I want field? I want field here. So what I do first?
So when you say here,
I
do you
tilt the
mean?
finger
So one
by
second.
90 degree in order to understand it. Okay, dear?
So can I ask a question?
It's over here. I will not be able to show it over here. So what I do, I tilt it by an angle 90 degree for you to understand. So I'm tilting it by 90 degree. From here, it comes over here. Yeah. So which is the point I want to find B field at this point, right? I will reorient it later. For now, the point is actually over here. It has been tilted by 90 degree to show it on green board. Now, what are the values known to us? What we don't know? Right, in terms of this angle, this will be 90 minus alpha. And then I go to the other angle which is not visible to me. Think about the other angle. The other angle, it goes to infinite. So this angle will be how much to us? Pi by 2. Check it out here. One angle is pi by 2 minus alpha. If alpha is an arbitrary angle taken, which defines position of the point. Then the other angle will be 90. Because the other end is not visible to us. What is the B field equation in this condition? What will be B field equation in this condition? Mu naught 4 pi I by whatever is the perpendicular distance, let's say R, bracket open, sine 90, 1. Sine 90, 1. And the other angle is what to us? Sine 90 minus alpha. Just a second, part will get restored. Sine 90 is one angle, so sine 90 is for us. The other angle is 90 minus alpha. So sine 90 minus alpha. Right here, are you able to recollect what we do for a wire? How do we get equation for a wire? If it is infinite, we get it as mu naught 4 pi sine 90 minus of sine minus 90. Can you recollect it? If it is infinite, mu naught 4 pi I by r we get, and sine 90 minus of sine minus 90 is what we get. So 90 plus 90 makes, the 2 make 2 there, thereby getting mu naught 4 pi twice I by r. That is what is the case. That is what is the case with us. Mu naught 4 pi 2I by r. That is how we get. Here in this case, we are getting the angles as, one angle is 90, no doubt about it. But the other angle is 90 minus alpha. What is the other angle? 90 minus alpha. So what do we get? Mu naught 4 pi sine of 90. Come here, you can keep it open for now. Actually, I am in campus DPS East Patna. This is, yeah. Right. Okay. Yeah, look over here. So this is what we get. Mu naught 4 pi. Now one of the angle is 90 and the other angle is 90 minus alpha. So what we can write? Sine 90 minus alpha will be what to us? Cos alpha. Please be careful about direction, class. Direction. How is the direction? I'm curling my finger. So how is the direction? I'm getting in this direction. Are you in agreement? All of you? Same page? I curl my finger. I make circles. I'm referring to this point which has been tilted by 90 degrees. You're aware of it. So if you calculate over here, it'll be into the board, right? Curling a finger, it'll go into the board.
Yes.
But to reorient and bring it back, then it will be in the direction away from me. Can we say that? It will be in this direction. Getting it? For which part? For this part. For this part. Tell me for this part now, please. This one. What about this one? This one means the wire is this way. This is the wire. Okay. Again, after curl my fingers, I'll be getting it outwards this way. I'll be getting it outwards this way. So outwards, I'll subtract. But first thing first, I need to know what are the angles subtended by this wire. This one, this wire. So one angle, of course, will be 90 degree. You are aware of it because the reference over here remains. So one angle will be, of course, 90 degree, right? Check it out. Check it out. Where do I want to find? Please be very careful. Where do I want to find? I want to find again at this point only, which is being oriented and kept over here. So for one wire, I got the angle 90 minus alpha to 90. Now the wire starts from here. So what are the angles I am getting? What are the angles I am getting? 90 minus alpha and 90 again. But the two angles are in the same direction. Agreement? Here I would have written plus. Why? Because one angle was 90 and the other angle was negative, right? So this will be plus. Check it out. This is plus. Why? Because it is to the other side of the line reference. Down, up, down, up. So up will be positive and down will be negative. Therefore, this will be plus. In this case, the other case here, the reference is this. And both the angles, 90 minus alpha, are in same direction. Agreement? 90 minus alpha, check it. This is the reference. 90 minus alpha, this is the point from it begins. So 90 minus alpha and 90, both are in same direction. So what will be the B field marked? Mu naught 4 pi I, whatever we are taking I or I prime by R remains. and bracket open, one angle, sine 90, the other angle in the same direction, 90 minus alpha. Same direction means anti-clockwise both the angles. So minus will be retained this time. What will you get? Minus of cos of the angle alpha. Please do check class. And this is, by the way, out of the green board when it is kept this way. And when it is reinstated, then it will be towards me. Is it as of now? Out of the green board. When reinstated, when brought over here back, then it will be towards me. So this one was away from me. And this one is towards me. What do we do in order to get in totality? One minus the other, right? One minus the other. So if you'll do the subtraction here, what you'll be left with is mu naught 4 pi I prime by r, and then twice cos of the angle alpha. Please do check class, endorse it. Please do check, endorse it.
So what was the last factor? 2 times cos alpha.
Twice cos of the angle alpha.
Yes, seems right.
And this field will be in which direction? Obviously the one which dominates, which is domineering. The one which is domineering is away from me. Away from me. If it is reoriented, I'm speaking to the term when we have reinstated it. So away from me. This entire, therefore, this line, one in this direction and the other in this direction, gets me at this point a field which is mu naught 4 pi I prime by r twice of cos alpha, where what is alpha is apparent from this figure. Check class. Much to comprehend. Much to comprehend. Do check. Anything to ask? Please feel free. This you will not get solved anywhere. They will be using very important so as to occult, I would say, or dupe you phrases. They will say that it cannot be in that direction, it cannot be in this direction. Why? Because it violates something. That's something we are alien, we are completely beyond. So don't fall for those. See for yourself the way that we are decoding it. We are going down to the last thread of dissection. The last denominator it can be brought to. Check please. Though, said that, it's not over. Much more to come. This is just one of the umpteen scores of wires that we have. Just one of them. This way, this way. May I ask Vasudev to throw some light if I take this wire, Vasudev, this way and this way, this way and this way. I take now a wire which is tilted. Point remains, point is this only, it is over here only. But now due to this wire, this way, this way. Tell me how to get the direction of B field first due to this one.
So you could just apply the alternate right-hand rule and get the directions. I think the calculations are going to be the same as the previous one, but only the distance, as in this case, r, would change. And the direction.
Come again, please.
I think the calculations are going to be similar to the last one. The only thing I think that will change is r, or the distance between the point, perpendicular distance between the point and the wire. Also the direction of the field, of course.
Okay. So what do you think will be the direction over here due to this wire? Will it be somewhat like this?
Yes, sir.
All of you convinced, please do check the chalk orientation class. It will be somewhat like this is what I'm saying. Getting it? Why will it be? You draw circles. You draw circles now, and you'll get to see that you're getting it in this direction. Please do check. Ishita, are you able to convince yourself on this? Because I'll be drawing circles. Are you getting it, Ishita? I'll be drawing circles, and it will not be this way. Why? Because this way will be just above the line. It is not above the line, so I'll be drawing tangent. I'll be getting it this way. I'll be getting it this way, right?
Yes, sir.
Ishita and Vivar, do I have the both of you commenting on the screen? Technique. This way.
Circle.
This way.
Sir.
You're drawing circles, Ishita. You're drawing circles. Are you getting it? And then you draw tangent on that circle at this point. Because this is my point of interest. My point of interest is above this line. Here. But I'm drawing circle with this as the axis. So when I draw circles, I'll get the orientation slightly up, correct? It will not be this way. It will be this way. It will not be this way. It will be this way. Are you getting it?
Yes.
Yes, sir.
Okay. So here what I do, I first break it into two components. One is on the surface, green board, and the other up. I repeat, I have got this way. Making some angle with green board is what I'm getting. I'm getting this line making some angle with green board. What I do, I break it into component. One of the component lying in the green field and green board, and the other component vertically upward. One in the green board and the other vertically upward. Why? Because I got it in this direction. Got it?
Yes, sir.
So I get one B field this way and the other vertically upward. I'm drawing it over here. Though it is up, but I'm drawing it over here. One B field I get this way. It is up, it is over here, as you know. One B field I get this way and the other vertically upwards. This is due to this wire. This is due to this wire. And this wire, when you will bring in, it will only peter out the magnitude. Direction remains, correct? Can we say that? As you have seen here. In this case, what happened? Direction was dominated by this. So here, no exception. Odds with the previous. Direction will be dominated by this. Yes, it will be petered out. It will exacerbate. Exacerbate, yes, it will be attenuation. And we will be taking that attenuation. Direction remains, which is this. So we got one as this and the other upward here. One is this and the other upwards. Upward, for the time being, I keep as it is. I want to focus or shift my focus on this one. This one will break in two component. I'm breaking it into two component, which is lying on the plane of board. I'm breaking the two components parallel to the plane of board, I would say, to be precise, into two components. One is this and the other is this. I give it to you. One is this and the other this. Getting it, class? Getting
Yes.
it too? Okay. I will call you in some while in the class. I'm in the class.